see, might be a little mistaken here. Let's see some examples. So begin word is hit, end word is cog, and the word list is hot, dog. Okay, log, cog, right?
There could be any
So
number of possibility. We are just required to return the shortest possible transformation. And each
yeah,
time we are required to just change one letter for
yeah,
transforming to
yes,
one word further.
yeah, definitely. I feel like, let's say if I'm starting from hit, right?
Hmm.
And I go through some words, let's say some X words I go through, and then again I see there's a possibility to reach hit again. I won't do that because that will again be a repetitive cycle, right?
Yeah, for
So,
that you need to keep some check that you need to,
correct.
yeah,
Yes. So in this case, they have an explanation. I'll just go over this. So from hit, they are going to hot. Okay. Why this? Okay. So they are differing between I and O.
yeah,
Okay. And then from hot, they are going to dot because it's differing between H and D. Okay. Oh, okay. So it's like this. Okay. So from hot, okay. So from dot, they're going to dog because it's differing in T and G. From dog, they are going to cog. Okay. There is a mistake here of this thing, but it's completely fine. So they are differing in D and C. Okay, which is 5 words long. So that's one, two. Okay, so that's, yeah, 1, 2, 3, 4, 5. Yeah, that kind of made sense because what I demonstrated on the screen. So for this, we have hit and cog, hot, dot, dog, lot, cog. So instead of cog, we have log here. Okay. The end word is cog is not in word list. Okay. Therefore, there is no valid transformation sequence. Okay. Oh, so one thing, first of all, like before even beginning anything, I know that if my end word is not even in my word list, I would probably return 0 because there is no way I can reach the end word.
yeah,
This might be thought of as an how do I put this out? Edge case, right? Because
yeah.
the end word is not even in the word list. So that's one observation. So again, I'll be trying to write it in Python. So maybe I can just quickly write down one observation that if end word is not in word list, simply return 0. Yeah, simply return 0 because answer will never exist. This is one edge case. So maybe I can type it in this way, edge case. Okay, sweet. So it's not necessary that the begin word need to be in word list because it can be, it may not be, right? So that's one thing. Okay, yeah, that's about it, right? So yeah, one thing I can think of right now straight away is that uh, I will probably pick the begin word. In this case, let's say hit, and I will try all possibilities. So I can probably say that I will go over all the word, well, in this case, word list. And yeah, I will go in all of these word lists, the words, and then I'll try to match hit with hot. I know that's a match. So maybe I can try a combination with hot. But let's say I had something like, so let's say in this case, we have uh, hot, and then let's say we had something like um, lit, right? So I also know that hit will also match with lit, right? Because H kind of is different with respect to L. So maybe there could be an answer, a shortest path starting from hot, or there could be a shortest path starting from lit. So that's the primary reason I can probably, yeah, I can probably do all combinations, all possible combinations. So hit with hot, and then again for with, and again, starting from hot, I will try to match it with all the possible combinations. Yeah. So, and also I will make sure that if I'm at hot, and let's say if I'm at hot, and then again by chance, by nature, I find out that hit is there in my list. Again, I won't visit hit because I went from hit to hot and then again to hit. That won't make sense because that will be a repetitive cycle. So maybe I can keep track of a visited. Yeah, I can keep track of a visited set. It could be a set of words which will keep track that, hey, this word has been visited, so don't visit it again. So that could be one thing here.
Okay.
Yeah.
Was there some
Yeah.
network
So
issue?
could you repeat?
Was there some network issue because I said okay and then you hadn't responded? In some latency?
No, no, it's absolutely fine. There's nothing as such. Okay. So what I'm thinking of is that at a particular word, I have the option to maybe pick it or not pick it. Dot, I can pick it for the sequence or I won't pick it, and then so on, right? So this will be more of like generating all the subsequence of words and then trying to map which one is the shortest one.
Okay.
Yeah. So should I begin with that?
Uh, as per the constraints, if you go ahead, means either selecting or not selecting, means either thinking of going with recursive solution or
Yeah, recursive solution.
okay. And in that recursive solution also, like in which context are you going ahead? DFS or you want to go ahead with memoizing at some point?
So when I'm trying to generate all subsequences, I have not yet thought of memoization because what I'm looking at is probably time complexity of uh, how do I put this? So my time complexity here I'm looking at is a big O of 2 to the power of n. So uh, wherein n is the length of the word list.
Okay.
But yeah, I have this strong feeling that the word list length is 5,000, right? Worst case. So 2 to the power 5,000 would be a very big problem for with respect to constraints, right? Hmm.
Okay.
So maybe like since can I have 1 minute? Just looking at a few things here and there. So
Sure.
yeah, so I just want to figure out one thing. So we have hit, right? Um, from hit, we go to, let's say, bot. And okay, so at hit, the number of distance covered is 0. And I'm just trying to find out a pattern here. This could be solved in a much faster way. So at hot, if I go, I'll be able to go in one distance. From hot, I can go to dot, right? So I can go to dot in, let's say, 2 distance. Then from dot, I can go to dog in distance of 3. And from dog, I can go to, they are saying hot dot dog 2 3. So initially, like, by the way, this will be 1, this will be 2, this will be 3, and I think so this will be 4. So from dog I will be able to go to dog in 5, something like this. But what if I find out at any point of a time I can reach dog from hit in 3 steps, then I will replace the value with 3. Some measures can be taken like this.
But
Or yeah, I feel like this is more of uh, shortest distance problem because yeah, I have to find the shortest transformation sequence, which is translating to shortest distance, right? So one thing that comes to my mind is again, BFS, not DFS. DFS will again scratch through all the paths and might end up taking longer time in finding the way to cog, which is the end word. But BFS will, I think so, ensure that I reach the cog at the very, like I will reach cog when I reach cog in terms of BFS, that's the point I will return the distance because I'm going breadth first search way. So that will probably uh, end up giving me the shortest path to cog. I think so. That's something I'm looking forward to.
yeah, okay.
5,000 and then 10, right? Yeah. So yeah, I think so. I can probably make use of Q data structure and a visited set. So yeah, um, something I'm looking forward to. Also, one more thing is that um, let's say the word I am at is hit, right? And I want to know that what are all the possible combinations that will go along with hit, right? So one way is that if I'm at a particular word and I want to know all possible combinations I can pair up with this word. One way is to simply loop over this word list length, right? So that's going to be for each word loop over 5,000 elements in the worst case. So again, let's say I'm saying for each word, right? So in the worst case, there could be 5,000 words. And for each word, I'm looping over 5,000 elements. That's going to be, I guess, 25 multiplied by 10 to the power 6. That's going to be something like this, right? Which is again quite huge. So to already know beforehand that over which words I can go over, the best way to do that would be that if I'm at a word, then let's say the word is um, ABC, right? And I want to know what are all the possible combinations. So what I'll do is I will simply run over, I will simply run over the very first character, and then I'll try to form words like BVC, CBC, uh, DBC, and then so on until I get to something like ZBC. So what this will ensure is this will go for at max for each of the characters. This will go for at max 26 times the length of particular word. So from something like 25 cross 10 to the power 6, I'm reducing that down to 26 cross length of word. I hope that kind of makes sense. Is
Yeah,
that something which resonates with you?
yeah, it's fine. You
Okay.
can go ahead with coding
So,
part for same, but before that, what would be the time complexity and space complexity both for your solution?
okay. So the time and space. Okay. So what I will do is I will write it here itself. The time I'm looking forward to is going to be big O of mm, n multiplied by, okay, so by the way, what is n here? So n is going to be the number of words in the word list itself. So it's going to be n multiplied by uh, 26 multiplied by the length of a particular word. In this case, the word length at max could be 10, right? So when I'm looking at the worst case scenarios, when the test cases, the constraints are huge enough, the time would be boiling down to 5,000 cross 26 cross 10. So it's something I'm looking forward to.
Okay,
Yeah. And with respect to space complexity part, I think so. Um, yeah, I have to create a set. So a visited set that will be n plus I have to check, excuse me. So when I'm generating all the words, I can visit from hit. So from hit, I can generate, let's say, AIT, BIT, CIT, DIT, and then so on till ZIT. Then I'll fix H and T, and then I'll change I. So that will be HAT, HBT, HCT, and then so on, right? So to check that the newly formed word is present in my word list or not, I have to maintain a pre-created set. So again, that set operation for that set operation, again, the space would take a n time complexity. So this is what the space I'm looking at.
okay,
Yeah. So should I begin?
yeah,
And can I use collections module to help with the queue part? So I can import BQ.
okay,
Okay. So from collections, I'm going to import BQ. And what I will do is I will keep track of something like let's say this could be word list. And okay, I'm not changing this one. So I'm saying that unique, and unique is going to be a set of my word list. Yeah. So set of my word list. So this unique is going to help me identify if that letter or if that newly formed word is present or not in approximately big of one time. So this is why the unique set is required. What I'll do is I'll create the queue here. So it would look something like this. And since this is a BFS process, and I don't see any multi-source BFS angle to this question. So I think so this is single source because hit is the only part where I can start from. Before even going into any one of these, in the unique, I will check something which is as follows. If my end word not in unique. So if it's not there, I will simply return 0. What I'm doing here is I'm handling the edge case, which I have already demonstrated in the comments at the very beginning, right? So if n word is not in unique, I'll return 0. Now in my queue, as a part of the next step, I will have my begin word along with a value 1. Now, why is this value 1? So how is this format stored? It's storing something like a word and the, how do I say this? Distance, right? Till now, distance covered till now. So from hit, if I'm starting, that's one distance. If I go to hot, in my queue, it will be appended as hot, comma 2. So I hope that resonates with you. Now, I will say while my queue exists, so this is again similar to while my length of, my bad, while my length of queue is greater than 0. It's kind of similar to that.
Okay.
Now, what I can say here is that my current word and my current distance is probably q dot pop left. Okay, and yeah, q dot pop left. And now what I'll do is from the current word, try all possible, uh, or I can probably say generate all possible words, but by only changing, my bad, but by only changing um, one character at a time, right? So, so I can maybe, yeah, yeah, that kind of, yeah. So, so basically ASCII value, I want to get clarification on, yeah. So I think so, all of these things are lowercase, right? So lowercase English letters means ASCII value I'm looking at is 97 to 122, because 97 is small a and 122 is small z, if I'm not wrong. Yeah. So yeah. So in here I will probably say, so for each character of the current word, right? So for I in range length of current word, here I can say that my new string is going to be basically current word till I. Okay, what I am doing here is known as string slicing in Python. So I hope that's something which might resonate with you. So new string, so I can probably get this part here and make sure that I'm focused here. So my new string is going to be currently current word till ith index. So let's say the word currently is, right? And let's say I is at C, right? So new string will be initially initialized at AB, and then the C will change as A, B, C, D, E, F till Z, and followed by B, D, E, F. B, D, F will be constant. So I will manipulate it in a moment. Or I could even say this, give me 1 second. For I in range length of current word, for J in range, notice I'm going from 97 till 123, because this range parameter will take the starting point is 97 and the ending point will be 1 less than the end point. It will go till 122, my bad. I hope that's pretty much clear to you. So I can say my current new string, or I can say my new word formed here is going to be, so current word will be there till I, right? 0 till I plus, so I'm looking at 97, right? So initially when I'm at 97, how do I form the character in Python? So I think so it's CHR of J. So this CHR of J, CHR of 97 kind of translates to small a, okay? CHR of 98 translates to basically small b, and then so on, right? And then I can probably have current word, and then this will be from I plus 1 till the very end, right? So this is how current word would be, yes. Now I can have a small edge case here. The thing here is that if my new word is equivalent to the current word, right? What will this do is it will check that, okay, let's say the word was ABC and I am manipulating the middle letter, which is B. So firstly, it will form AAC. Then when it forms the new word as ABC, that's similar to the current word, right? So that kind of makes sense to that. I will skip that. I hope that's clear.
Yeah,
If that's not, I will, okay.
it's
So
clear.
in that case, okay. So in that case, I'm saying continue. That's a statement I'll use, continue. So I don't need to look into that. I will just continue the loop. Else what I will do is, okay, I have to keep track of a visited set, right? So visited is a set, and my bad, visited is a set. And also I'll have to put in visited dot add begin word, right? Okay, so visited dot add begin word. So what visited is going to keep track is it's going to keep track of the already visited words. So we don't visit them again. That's it. Okay. So we don't visit them again. Small grammatical error. Yeah. So in this case, I can probably say that what will I have to go? So like if my new word, yeah, if my new word not in visited, right? So if it's not visited, but my new word is in unique. Now, why am I checking both of this? You might be like, hey, it's not in visited, so I'll put it into queue. No, I have to make sure it's not in visited as well. And it's not even in the word list. I mean, it's in word list. I hope
But why
that
you
resonates with
require
you.
but why you require this visited? Like you can is why you require this visited.
Okay, I could probably remove from unique only, right? So if it's there in unique, then I will remove it so that next time I don't have it. I can do that. So let's say in unique, we have A, B, and C, right? A, B, and C. And let's say I'm saying if A not in visited and A in unique. So
But
what I will do here
this
is I will,
unique is already a set, right? So it won't store anything duplicate. So why you required to have a check that it is there in unique or not?
the reason is because let's say the new word formed is ABC,
Hmm.
and ABC is not even in unique, which means ABC is not even in the word list. So I won't visit it. It's because of that. So if the current word is not visited and it's in the word list, so I could probably say this as word list, let's say, then this would make sense at your end, right? Because if ABC is in my word list and it's not visited, then I will visit it.
Okay.
Yeah.
But I
So
feel like
that's
there
the
is
main.
no requirement of visited because unique would handle the duplicate case. So even if you visit it again, means like uh, the thing is that every time we are just changing one character. So in that
Hmm.
sense, we it won't be adding up to much of the time complexity part if a particular word repeats in three or four words again and again.
Okay.
So in that sense, I don't think so there is requirement of visited.
Yeah. Kind of makes sense. Okay. Hmm. Okay. Maybe I can get rid of that. Yeah. And yeah, I will manipulate unique itself. So I can say if new word is in unique, which means it's in the word list, um, then I'll probably remove that word because I don't want to visit that word again. And I can probably add it to my queue as well. So queue dot append, um, probably my new word will come up here, followed by value distance plus one. That could be one way.
Okay.
And then yeah, and then I think so. I also need to make sure uh, to check this that if at any point of a time I reach the end word, then in that case I will return. Okay, so there's a 10-minute mark. We can probably get over with this. So I will return distance in that case. So yeah, that's something I'm looking at. And end of the day, I will return 0 because I can't reach there because yeah, can't reach there. Can do something like this.
Okay.
Or Q is DQ, Q dot append begin word and 1. And my Q, I'm having the current word and the distance, right? So if my current word is equivalent to the current word, then I'll return distance versus BFS. Anytime I return end word matches, so distance is returned, right? Now here I am forming the new word, right, as follows. So if my new word is equal to current word, I'm skipping that part. And if my new word is in unique, in that case, I'm removing it from unique because if I re-encounter that new word, I won't visit that. Word. Yeah, can I run this if it's
Okay.
fine?
Is
Yeah.
it end of the code?
Yeah.
Okay.
Yeah. So I think so. It's giving me the right answer. 5 for this
Out
test case. I can.
5 and okay. Expected one
Um,
is also 5. And
yeah.
check for other test
Uh,
case as well. That will also work fine. Okay.
yeah. Can I try this one to
Yeah.
replace the test case? Hit cog and
Just replace the word here.
set this.
Or just remove the cog from that.
Oh, okay. My
Okay, yes.
just copied it. So yeah, it's 0. So works fine for me.
Okay. I guess I need to check from my end for submission of the same.
Okay. Yeah. That should be it from my end for this problem.
And we are also running out of time.
Yeah, we have 7 minutes left. So should I reshare my I mean should reshare the link and I'll share it here itself.
Okay, yeah, you can share the link
Yeah,
again.
I'll share it in the editor here itself.
In this lead code editor.
Yeah,
Okay.
yeah.
Okay. Now follow-up question for the same.
Okay,
Previous. Okay, let me check how much time you took for the previous one. So it was almost
okay.
30 minutes. So we have just 15 minutes for the next question.
Mm.
Is the question visible to you? Yeah.
Yeah, you have changed or
Yes, yes. I've changed. It's second question. It's the follow-up for the same question.
yeah, I see the output is different. Yeah, so I was a little uh, mistaken here. Okay,
Here
okay.
you are
So
required to return with the sequences as well. That's the change here.
Okay.
Earlier, you were just required to return the length, but now you are required to return those sequence as well. So you have 15 minutes for the scene.
Hmm.
You can either tell me the approach. That would also work.
Okay. So the question kind of remains the same, but as you mentioned that I have to return the sequences and all of it, right?
Yeah.
Okay. Excuse me. So we have hit hot. That's 5 moves, right? Then from hit hot, instead of dot, we are going to lot, then log, and then cog. Okay. Explanation is that there are two shortest transformation sequences. Hmm. Okay. So from hit, I'll reach hot in 2 steps, dot in 3 steps, log in 4 steps, cog in 5 steps. But here, I think so, yeah. Hmm. Here it's more like even if it's visited it, I am bound to visit it again. So it's more like the visited or the unique thing won't really help us here because from hit I went to hot, then dot, dog, and cog. So it's more like I have to visit hot again. So I visit hot again, then lot, log, and then cog. Okay, so from hit when I visit hot, it's going to be hot, comma 2, because that's hot, comma 2 distance. From hot, I think so I'll be able to visit dot and lot. From dot, I'll be able to visit dog, cog, lot, log, cog, yes. So again, and edge case here, I see that if the word is not present in the word list, I'll return an empty list, something I'll be able to do.
Yeah.
And word list length this time is 500. So there's a 5,000 to 500, right? Could probably make use of that, but let's see. Okay, so I'm just doing a little visual representation in my head. This is not the actual solution. So if I'm at hit, then I'll try all possible 26 combinations. I see I can go to hot. I'll go to hot with some distance. So I'm not looking at the distance right now. And then from hot, I will be able to go to dot and lot, right? So it could be presented as dot and go to lot. And then from dot, I can go to log. No, from dot, I can go to dog, my bad. And from lot, I can go to log. And then from both of them, I can go to cog. Yeah. Huh. There's a lot of possibilities here. Yeah, what I'm looking forward to is that, again, like it could be a very similar process wherein I basically start from hit and then okay, so first of all, what I will do is I will firstly um, try to find out the shortest distance. Okay. So firstly, I'll try to find out the shortest transformation. Let's say the shortest transformation length is something I can get via the previous code which I had written. I can write it down again. So that will give me the answer 5. And once I have the answer 5, what I could do is I could probably find out all the subsequences which kind of lead to cog at a distance of 5. That will kind of reduce the pain for me. Because if I don't have the shortest transformation beforehand, then I might reach,
Okay, got it. Means some another word. Yeah.
yeah, I could reach cog in this step, but I would never know that is this the shortest or not. So it's
Okay.
better to know, yeah. So that's something of an approach which I think right now.
Okay, you would be able to figure out the shortest distance from the previous code. It's fine. Then what about the each subsequence, which is there, means each transformation sequence, which is there? About that is how you will figure out for the same. Would it be from previous code only or something new?
I don't feel like so from the previous code will never give me the previous code can give me the answer hit, hot, lot, log, and cog. That I could retrace back with the help of uh, something which is I'll just remove this. Yeah, so let's say I traced this down. So when I was at hit and I'm going to hot, I would maybe keep track of something called parent. And in this parent itself, it will say that the parent of hit is hot because I'm going to hot. And then it might say that the parent of hot is probably lot. Then the parent of lot is log. Parent of log is cog. So I think so using this, I can kind of retrace the path. So from cog, maybe I have to, yeah. So maybe I can just go from hit. Then I want to go to hot. So from hot, I'll go to lot. So this way I will be able to trace the path, but that would only give me this path and not the other path itself. Or there could be hundreds of paths, which is of length 5. That might not give me the other ones. It will give me only one because I'm making use of unique, which kind of states that if let's say hot was, so yeah, if a word is visited already, we won't visit it again, right? So
Okay. And how that
maybe
approach would be implemented in the case of me? Would you be doing some means would it be BFS or how it would be implemented for this case? Means keeping track of parent, how you will be doing that.
so that parent could be, yeah, that parent could be easily represented as follows. So I know that this hot has two of its child, right? Dot and lot. So that could be maybe represented in the format of a small list, lot, and I guess dot. But again, for each one of these lot, I have to map something which is log, and then so on. This might continue. So I could probably use one data structure called try, which might help me in storing the value. So in my try, this might be stored as follows. Um, so initially I have hit. So based on the answer, looking at the answer, what I think is hit will be pointing to hot, which will be pointing down to log, which is pointing to nothing right now. And then, okay, so it will point into lot. And then hot is again pointing to dot, which is pointing to nothing, right? And then again, this lot is going to point to log, and this log is going to point to something like cog, which is pointing to, again, nothing, right? And then again, from dot, I can probably go with log, which is again pointing to um, cog, right? And which is again pointing to nothing. So maybe using this kind of a data structure, this could be represented in the format of a try. I can probably trace down the path of all the paths which is of length 5. That's something I can do. Also, I know one thing that when I create this try, I won't create it past length 5. That kind of means that if I'm at hot, so let's say I form something like this. Apart from this, I am forming something like, let's say hit, then X, Y, Z, R. So that's 1, 2, 3, 4, 5. I know that this R, if this is not cog, then it never makes sense to probably have cog later on because I will never go past 5. I hope that kind of answers my question, answers my answer. I mean, that kind of makes sense.
Yeah.
So I will create the try of at max length shortest transformation itself. something I can do.
Okay. And what would be time complexity and space complexity for the same?
Yeah, so the time and space is a little tricky here, so I'll give my best shot here. So the time here I'm looking at is, and the space, right? So, okay, so the time here I'm looking at is, so since all the words are unique, right? Yeah, so all the words in word list are unique. The sum of all the shortest transformation sequences does not exceed 10 to the power 5, right? Mm, so from here, I'm transforming into that. And then if that matches, yeah, so end of the day, like I am going to access all the n elements. Yeah, I'm going to access all the n elements, and yeah, to form the new word, which is using that same character transformation, a till z, that will be 26. And once I have the transformation for it, I can probably put it in the try, right? So from hit, I'm accessing 26 characters. I'm forming the words, length of the word. I'm going to improve on this. So let me think about it. So from hot, I'm accessing 26 characters and then length of word. Then, yeah. And then if it's actually matching and it's in there in the word list, I will put it in the try. Right? Yeah, I think so. The time would be pretty much this itself.
Okay.
Yeah, and the space complexity I'm looking at is, see, the try is going to be, yeah. So I'm looking at n cross n. The reason is because, yeah, so maybe there could be a possibility that, let's say the hot is storing all of these characters, right? But then again, I saw that one more hot was storing all of these things, right? So a particular word is storing, let's say, n words in total. And then again, that word is again storing, like, let's say, these many words. So that kind of translates down to somewhat of an n square time complexity.
Could you repeat again? Y n square?
Yeah, could you repeat?
I'm saying means could you repeat again y n square?
Yeah, so what I'm thinking is that if I'm at hit, then let's say from hit, I'm able to go to hot, which is absolutely fine. But I see from hot, I have two diversions, right? I have two diversions. So in this diversion, I have, let's say, dot and then few other elements. And then here I have lot and then few other elements and then so on, right? So again, for each word, I could have probably stored all the words, right, in all of them. So I see all of the words are stored till the very end. And in here as well, all of the words are stored till the very end. So
Uh, as in this example one, it is about two sequences, but there could be some more sequences than that.
okay, so maybe like hot might be having something like dot, lot, and then X, Y, Z, right?
Yeah.
So yeah, that's going to be, I guess. So this hot is never going to have more than 26 subsequences, to be honest.
Yeah.
Right? I mean, if this hot is having dot lot, then it will never have more than 26 of it. To be precise, yeah, not more than. Um, so if this is changing, then I have 26 possibilities. That's going to be n cross 26 plus 26 plus 26, I guess. Because for each character change, that would be this, right? So uh, this could be translated as follows. Give me 1 second. 26 cross length of the word, because for each one of them, I could translate it as follows.
Okay.
Hmm.
Okay. Uh, for time being, we are already out of time.
Yeah.
So yeah. as we are not going ahead with the coding for the same. So it's fine for the time being. No. So any questions for me?
Yeah, one thing which is going on in my mind is, do we need to use try here, or we could do using the previous process itself?
It is not necessary to use try here. We can even
Okay.
do try that BFS, and even with that BFS also we can do.
Yeah. Okay. Maybe like stopping until 5 moves, right? Every single time I go past 5 moves, I'll not take that into my queue. I can do that.
Yeah.
Okay. And that will help in the parent array itself. This try is not needed, I guess. Yeah. That could be populated in the parent array. Correct.
Yeah. Okay, then
Yeah.
we are ending up this interview. So that's all.
Yeah.
For the stopping
Yeah.
this.
Thank you. Yeah.